Midterm review number 61. We're solving a system of equations algebraically. The first equation is an equation of a circle. I know this because both the x variable is squared and the y variable is squared, and they have the same leading coefficient of 1 in front. The second equation is a linear equation. I know this because both the y and the x variable have an exponent of 1. In order to solve, I'm going to take the simpler equation, the linear equation, and isolate y. To do that, I'm going to first divide all terms by 2. I get y minus x is equal to -1. I'm then going to add x to both sides of the equation, and my transformed equation is x minus 1. I'm now going to take the right-hand side of the linear equation, x minus 1, and I'm going to replace that y with that value of x minus 1. I get x minus 2 squared plus parentheses x minus 1 plus 1 squared is equal to 10. Notice that the negative and 1 cancel. Sometimes you just combine the results and there's still a constant, but in this case, there is only the x variable left. Remember to square your binomial. So this is really x minus 2 times x minus 2 plus x squared is equal to 10. You're going to multiply this out either through FOILing or the box method, however you decide to multiply this out. Going to carry down that other x squared and set it equal to 10. I now combine like terms. So x squared plus x squared is 2x squared. Minus 2x is minus 4x, plus 4 is equal to 10. It's still not in standard form. It's a quadratic equation, so we need to have it in ax squared plus bx plus c format. So to do that, I'm going to subtract 10 from both sides of the equation. I get 2x squared minus 4x minus 6 is equal to 0. Now this is a quadratic equation, and there are multiple ways we can actually go from here. I could use the quadratic formula, but this is factorable. To make my life a little easier, I'm going to divide all terms on both sides of the equation by 2. I can do that because it's an equation. I get x squared minus 2x minus 3 is equal to 0. This quadratic equation is factorable. I'm looking for two values that add to -2 and multiply out to -3, and those values are x minus 3 times x plus 1. I solve both linear equations. And I get one x coordinate as 3 and the other one is -1. We're getting there, but we still need to find y, and I can actually substitute into either equation, but this transform linear is the easiest. So I'm going to take 3 and replace it in for x. This gives me a y value of 2. So one solution is 3, 2. Make sure to have it in parentheses. That's 1 point. The other one, my y value is -2. And my second solution is -1, -2. Now, you still need to check this information in the original equation. So since there are 2 solutions and 2 equations, there's a total of 4 checks. So let's first check 3, 2. Wherever I see an x, I'm going to replace it with 3, and wherever I see a y, I'm going to replace it with 2. That's 1. 1 squared is 1. 2 plus 1 is 3. 3 squared is 9. 1 plus 9 is 10, so that works. For the linear equation, that's 2 times 2 minus 2 times 3 is equal to negative 2. 4 minus 6 is negative 2, so that works. So now I'm going to check the second point. Negative 1 minus 2 squared plus negative 2 plus 1 squared, is it equal to 10? Well, that's negative 3 squared is positive 9. Negative 2 plus 1 is negative 1 squared is 1. 9 plus 1 is 10. And then the last one to check. 2 times negative 2 minus 2 times negative 1, is it equal to negative 2? That's negative 4 plus 2, and that works. So this is our solution.